In this video, we'd like to discuss how the number system we know of was developed, and that will kind of give us the idea of further extending the number systems and getting used to the numbers that we haven't studied yet. So just for now, let us forget that numbers were ever invented, and I'll tell you a little story, but we are not historians, so the story might not be accurate, but mathematically the story would hold, and this would give you an insight of what what was discovered when. So a guy in his stone age, in the stone age, he wanted to count his goats, and he didn't have any notion of the number of goats he had. So the amount of goats he had to somehow count, so that when they went for grazing and had to come back, he had to keep a count of how many were left. So what he started to do, he created a symbol. He used sticks to denote each goat. So once you have used this one symbol, for the next goat he will put a symbol next to it, and then for 3 goats he'll have 3 symbols. This will be for 4 goats, and he'll make a group of 5, so this will be the 5th goat, and so on. And this was the counting we knew existed long back. This was fairly useful for them, but when it comes to larger numbers, people actually thought that just one symbol might not be enough to represent numbers, so they created a set of symbols, and these are the symbols we all know and we are used to. So these were the symbols. There were 9 symbols, and then 0 was added in later, right? Famously, 0 was added in later, and these symbols were used for counting. So if you had to go past 9, something past 9, so you just keep using the symbols we already have. So we wrote 10 with a 1 and a 0, 11 with 1 and a 1, and then it goes on this way, right? I won't bore you with this a lot, but this was how natural numbers were created. So this bag of numbers, this list of symbols, or rather I'll write it this way because this goes on forever. So I'll put a comma separating each, and I'll suggest that this goes on forever using these dots, and I'll enclose this whole all these numbers in 2 brackets. I'll not write 0 for now. So this collection of numbers was called natural numbers. And if you add a 0 to the list, so to this same list, if I add a 0, so this would give me the collection of whole numbers. So we might be fairly used to all these numbers, but I just wanted to give you the terminologies for these and develop it further. Well, natural numbers and whole numbers, you don't need to be very specific about the naming, because it's often in modern mathematics people often use it interchangeably, but if you have to make a distinction, this is the distinction. Now people thought, well, what about if you want to represent a debt? So if a person is at a debt, so that means it's at a loss of something, right? Or if you wanted to represent the temperature of a freezer, or say the depth of a sea, right? So things below our ground level are 0. So we came up with a quite brilliant idea actually then, and we used these same symbols, but we used a negative sign before it, suggesting that, so if I say -1, it will be as much less as 0 as 1 is greater than 0. So if -2 will be as less as 0 as 2 is on the greater side of 0, minus 2 will be that much less than 0, and minus 3, and this would go on in the other direction, and then we'll have 0, and then we'll have our usual natural numbers, and these collection constitute the set of integers, the collection of integers. So integers were widely used for a lot of time till when we hit kind of a problem, and we realized that if you had, say, two pizzas, and so two pizzas, and we had 3 people to consume these 2 pizzas. So the amount of pizza each person gets cannot be represented as a number in this set, right? This is to say that if X amount of pizza has to be given to each person, and there are 3 people in total, and there are 2 pizzas in total, so this equation could not be solved using integers. And this notion we'll look at our next in our next videos, and it'll, of course you'll know the answer, but it'll give rise to rational numbers, and we'll develop further from there. Thank you for now.